然后他说
饿不起，这2天没吃饭，我感觉我瘦了好多。2天吃饭都挺瘦的。我这2天真的快疯了，我真的头会绑着，因为我也不吃多了，但是
但你要让这2天
不是不想吃
2个期
是没有吃，然后我那个怎么办呢？
你没戏了。
几乎每天都走上是这个他有一个因为我想睡觉，就是大概11点钟，就是2个小时，但是我在做程序，没法睡。就突然真踩进去，坐下去之后发现2点了，想很惊险，但是他就是这么做，我是想
买了，
因为我最后是做除了这个课呀，然后还有那个肯定是一样的，但是你看了我
那个网址一直输不出来。
那个海螺是
海螺太难做了，那个
他刚才问了，然后那个我说这个不是我的，就是那个老师觉得说这个是他自己能力的问题。
他对这个数，看我的海螺
他总共10万小时考了40分钟，然后只做了1到半段。
那怎么办？
没有，就老师都觉得他自己能力不行，所以出不来我们单机电脑课。
那这个找个老师解释也不行。
老师解释，然后小老师就啪。
这老师傻逼吧？教评语差评。
评哪个？
你们怎么我还没评呢？
反正就是这样。
老师特别逗，
就是他那个网址是一般的赛马场的
啊，
然后那网址他出来了，然后消费者就出不来，蹦不出来那个东西，就估计电脑那个网有问题还是什么的。
多鸟人用啊。
他们哪个老师说
他也天天做这个，我就要他做。我这几天就看到了，但是我觉得现在眼睛都快瞎了。
反正我是
什么版来着？就是那个
牙龈。
但是我觉得就
他就为了看看改不改符号，还画一个。他太扯了。
我聪哥那也不是。40分的话，1个半小时。
这个还要转一转，可以再把过程写。
不是100分的话，这个
一开始17行，后来就
我本来想今天晚上。
行，那我不然把那篇现在我就交了。
可能因为我不太喜欢。
我这里衣服就直接把手放进去清。
黄宇拿毛这一打。
我觉得我可以学霸了，瞬间人生轻松，至少今天轻松一点，要不今天不行啊。
有人写了这么多，有人写了这么多，
比较语言，我今天特别简单，可以选7个。
因为张宇是白饶的。
对他几乎举那个，他其实他的那么多人买，
那不要钱。
别不能抢
可能第1关不要钱。就只有几个那个大人的第1关。
啊，还好
我这个全你全打开了，他所有关他这也差不多过10道。不是，我也看，我说你所有关你打到了。我第1关你打到最高的话，肯定是我得打到。
我准备冲24级，每天
24级，你知道我是说我不是放美国多少钱，我只国内就是国内价钱。
你冲了200多磅，
不是，我直接啪冲100磅上去。
天呐，你又去，这是我还说的。
哦，这是
那个小，今天
就是
小
对，
我也是。
不是你那你要是起个150的话，
也就是说80多分很危险。
80多分
80多分很容易为了起跑。
包括美一样的，一个人200多分。你看上毛病，跟猪哥在一起，
那个太大了，
我大约4个月所有人都眼睛高一分，
你他们跟我明天不一样，他们都他妈
的一个都是7分。
这样子，我以为
我感觉
他感谢我，哎呀，我帮了，你看我帮他看看，
最右边是最稀有的，是不是最稀有的？
他每次自己拍都不好，非常人生比自己拍的好。他说这都长得120
最右边有一个是最神的，
但是我第一回，我好像太看不懂了，对不对？
最然后最右边到底
你是转过去是
里边收的。
他现在还会转那个
对，几乎是我
都这样，这帮的这样，这样都这样。
我虽然
就是很
但哦，你看那个电脑已经，
反正排名还是那样。
我知道为什么。
反正排名是
有什么惨的呢？
啊，我也想在我那儿帮我看一看资本前期的一个
啊，是他肯定好像
这个就是
不是，
但其实就是
但我都非常喜欢玩，我都会玩这种。
这黑金币特狗。哇，这都没有见过啊！
你还有其他。
就只有一个我们是完全是无产阶级。
你打不打？
就是我搞这个程序，对的，我听
就是那个，
因为他的思路真的太清奇了，就搞了我很久。哇，的刘海真是，长会更长会更
160到80，不是60那个总体卷子，
就这点长度，
那个卷子特别实用。但是我们要160乘以80，所以我才会就是这样。
这个
你有没有看过罗伟给我画的像？没。
但这次考试有画着我的衣服。
然后我今天同学还问我画你的头像，就是你本人一个大图帮我画，反正很好画。什么呀？
我们去年
那我们这个是
有5分折8是他一样的，就是那个。他比我找的高多了。就你只做60分的题，但是最后那个这个成绩要折成一个80分，一个小错。
真的这样子看，这样子很短很短。
缓慢手也是很快了，再搞2里，
Guys, you have questions you want me to do now? Yes. 不去了呀。奶茶3人组。
有贵的就挺贵的，好几千。我觉得会吹好的东西有效率。如果你只是专门搞的，肯定是不一样。
我的女朋友他也是去考试。
那好说，快我好不容易快看完，我就赶紧。这个超难，所以之前不是有一个
跳炸弹。
其实我觉
左按一小开。
报告已经报告在
You always on the phone, right? You guys have questions you want me to do? Are you ready for the exam? Why is that? I thought mine is the first exam, right? Is mine is the first exam for you, or is it the second? What is the first exam day? 19? 19? This one? All right, guys. Anyway, you have questions, guys. Let me know. Guys, yes. Yeah, just think about the graphing. I think the graphing rule is not really. The shape is correct, but I think that the points. I don't think the points are correct. Okay, he has this sense. The shape is correct. Yeah, the shape was correct. So I think the points, the coordinates you put are not. Yeah. Alright guys, you have questions you want me to do? Are you signing the energy? How you guys doing? You have questions you want me to do? You have questions you want me to do?
No, just thinking about the things that you education.
Normally it's 5%. Should just take it.
那个也不是溜哪一个字。
那我只能今天晚上为你我今天晚上绝对不学习，是跟你讲，今天娘们在图书馆，我绝对不学习。然后你要自己看书。哎，你看哪儿？你在里面看到我，只要你今天晚上看到我，这个节目看到我，知道吗？那你觉得下课都有道理。如果你这么想，可以现在就满足你这个愿望。都有个好的选择。我打那个，我哪个一个同学？我一个啥时候犯什么？
What about you guys? You have any questions you want me to do? No. What about you? You okay? Okay.
我想的这个就是
Just send me an email if you want it. If you want it. If you have questions, you can send me an email. I'll go ahead.
我不几个没点远看这个。每个人就是每个运动员偏我还想就这面上就这样。我那三角拍的是这样，因为反面尖的，然后正面轮子下来，然后这样的话你反手击球感和正手击球感是一样的。反面分组起来，正反两面的击球手感。没错，没错的。
You need to find the bias and MSC, right? So you need to find the distribution lines. You put the solutions on the you understand it? Which year is it? Is it 2000? Let me do it. Just give me a sec. I will do it here.
其实我们的最后一步都是就是看你怎么去。
Yeah, I'll do it, man. Steve, come here. Can you put this on? I'll do it. I'll do it over here. Just give me a sec. Can you put that on?
Yeah, I need to open this one.
Just give me a sec. I'm gonna do it on the visualizer, right? Give me 1 second.
Just give me a second. That is on that one. Yeah, only that one. Just give me a second.
Oh, how come this not working? You've got it, not coming.
Just put a mark on that so I can see. Yeah, it's only coming on that one. So this one's
Wait, wait.
It's not even turning on.
It's dead.
Maybe blow to that one.
Guys!
这叫绅士。
So can you see what I'm writing? Right? Yeah. So this is, guys, could you listen please? This is exam 2014-15. I don't know why this is not working, man. Still, can you check the camera here? I don't know why it's not working. Check the camera.
I just clicked it. It's look fine. Let me just. This is projector 2 or 1.
No, is it working or what?
It's working at the back, but I'm not sure why it's working.
This camera, yeah, this works. All right.
I don't know how to leave it though. Can't be related to this one.
All right.
I don't know.
Now to find the bias and the MSE of this one, guys, are you listening or what? To find, how do you find the bias and the MSE of theta 1 hat? Any ideas? First, all right, you need to figure out, all right, let now if you get lost, shout at me, okay? Shout at me. If you don't follow anything, just shout at me. All right. Now, are you with me so far? Do you follow me so far, guys? All right. Now, if the minimum is greater than z divided by 3, what can you say about each of these guys? Huh? You can say that yes, right? That's because if the minimum is greater than something, then each element has to be greater. Yeah. Now, because x1 and x2 are independent variables, this must be, because they all right, this is using independence. Yes. Yes. Right. Now the next step is I'm going to use the complement rule one more time. This guy here, you can write it as are you guys okay or what? Yes? I'll use the complement rule, alright? Now, Now if the absolute value of x1 is less than or equal to z over 3, that means that x1 must be between minus z over 3 or plus z over 3. Yeah, remember if the absolute value of something is less than something, that means it's either between minus of it or plus of it. Yeah. Now we know that x1 is a uniform random variable on the interval from minus theta to plus theta. So this probability here, guys, will be equal to 2z by 3 divided by 2 theta, and similarly this will be 2z by 3 divided by 2 theta. Can you see how I got from this to this to this? No? Why is that? Why can't you see that? What's the PDF of the uniform distribution, guys? Remember, is there a chalk here somewhere? Somebody has a chalk. Right, look. Now x1 is a uniform variable on the interval minus theta to plus theta, right? And you want to find the probability that x1 lies between minus z by 3 and plus z by 3. So this is simply the F is the CDF of the uniform distribution. Now, right, for the uniform distribution from minus theta to plus theta, what is the CDF? Yeah. Do you remember this? The formula for the CDF of the uniform distribution. It's in the lecture note, guys. Somewhere in the lecture notes. You know it, right? You know it, right? Yeah. You see some of your friend knows it. Yeah. Okay. So if you simplify this, then it becomes 2z by 3 divided by 2 theta, which is what I have written down over there, right? So all right, guys. So this becomes some of you seem lost sometimes. This becomes this, all right? So this is the. So what I have is it clear now or not? So this is the CDF of Z. Z is what I call this guy here. Right now, once you find the CDF, you know what the PDF is. Now, so this is the PDF. The PDF of Z is just the derivative of this. So it will gonna be 2 over 3 theta times 1 minus. All right. This is the PDF of Z. Now once you know the PDF, you can find the bias and the MSC. It's straightforward, right? So to find the bias, for example, to find the bias of theta 1 hat, all you have to do is just try and find the expected value of Z minus minus theta. So to find the expectation of z, you just need to do the integration. So it will be, I'm not going to do it, I will let you do this. So it will be the integral from 0 to theta of z times 1 minus z divided by 3 theta dz minus theta, right? So, and you can do the rest by yourself, I assume. Right, so that's the difficult part is what I have done already. I mean, the rest is just to find the bias and the MSC for theta 1 hat. I'm sure you can do that by yourself, guys. Yeah. All right. All right. Any other questions you want me to do, guys? I'm sure you guys have lots of questions. You have more questions? Or? Yeah. Now you know how to do it. Yeah. Good. It's a pleasure. What about you, sir? We have more questions? Not now? You guys, all right?
Yeah, I have more questions. I can ask bonus question.
No, you can't ask me. I did. Yeah. I did it in the lecture today.
So do I need to write? Something.
Yeah.
I have to write like this.
You understood why I did in the lecture?
Yeah.
You good. Very good. Yeah. Don't know what happened to all other people. They're simply not like one common. How are you, man? You have any questions? You okay? You have questions? The third formula, yeah, it's just a general formula to between the PMF and the CDX of the discrete training variable. I'll do it on the board if you like. I'll do it over here. Guys, could you listen please? This is a formula that you need to remember for the exam. Did you see this formula in the sheet? Formula sheet. Yeah? Yes or no? You saw it, right? Now let me give you an example. Now suppose x is x is a geometric variable. For the geometric variable, what do you remember the CDF of the geometric variable? What is that? Huh? No? Yes, no? We did geometric distribution, right? Is the CDF of it is 1 minus p power x. X from 1 to infinity. All right. Now, what this formula tells you is that if you know the CDF, then you also know the p of x, which is the probability mass function. So, knowing the CDF, you can compute the PMF, the probability mass function, by using this formula. So, what it says is that p of x can be written as f of x minus f of x minus 1, which is this, right? And if you simplify this, guys, you will get, we'll see what we get. 1 and the 1 cancel, so this becomes this. Take the common factor, you get minus 1 minus p plus 1. Yeah, and 1 and the 1 cancel, so this becomes p times 1 minus p. Yeah, so this, which is the PMF of, if you look at the lecture notes, guys, you will see that this formula is the formula I gave you. If you look at the lecture notes on page 2 or 3, I can't remember the page number right now. This is the formula for the PMF of the geometric distribution, right? One way to obtain that is using this formula here, right? Is that clear, guys, or not? So, I mean, this is a very useful formula because by knowing the CDF, you can work out the PMF of a discrete value, of a discrete random variable, right? Yeah. I thought we might have known this one before. Any other questions, guys, please? You're right. Okay, just yeah. I tried some of the method, but I just called this one here equal to k. The same thing. So because it's of the same, the projection rule that you get from the Riemann-Pearson lemma is of the same type as equation 98, and therefore equation 98 must be most oriented. That's what I was trying to say. Yeah. You all right, sir? You have no questions? How's you're taking algebraic structures? No, you're taking the introduction to financial maths, right? You should be taking. You're taking financial modeling. That means you have to work like 24 hours a day, 24 hours, like me. Oh, you said you're right. Thinking about more, like help me. Oh, that's yes, you're right. I know, but you will not be asked to do that. This here it is very difficult to use the number because it's not single hypothesis, it's proposition. You can't apply the NP number for this one. Yeah, one sample first, yes. Yes. Yeah, no, it's not easy. It's not easy. Yeah, that's correct. No, you keep quiet. You guys have any questions? Yeah. You learn it from property one. You guys okay? Any questions? You okay? You okay? Yeah, just this one. This one is just this one. Okay.
Yeah, I have small question.
Yeah. Sorry, this is a bonus question.
Yeah. In the likelihood function, do we use big capital or small?
It doesn't matter if it's capital or small. Doesn't matter. You can use it. I mean, you'll get the same mark here. Normally, you should use little x, but sometimes I also use capital x. But they are both acceptable. They are both acceptable. It's okay. Yeah. So it doesn't matter whether you use capital or little. Capital X is a random variable, whereas little x is an observed quantity. So little x is an observed data value, whereas capital X is like a random variable. Yeah. You know, so it's normally, so really it doesn't matter which one you use really. But if you're dealing with observed data, and people use little x. If you're dealing with random variables, people use capital X. Yeah. Again, it doesn't matter. I mean, some people use capital X, some people use little x. Yeah.
It's the same.
Yeah, it's the same.
Huh? Like they
you can use the paper. Yeah, but you need to write your name and ID number. Make sure you write your number, your name and the ID. Yeah. It's okay, it's alright. It's alright. I know you're not commanding, right? So it's okay. Yeah. You guys are okay? You finish your bonus?
Yeah.啥时候教开始？爱课上。太尬了，幸亏吧，我回去请你吃饭。
Guys, for the tomorrow's lecture, could you please bring some questions for me? Right? If you don't bring any questions, I will do examples for the examples program. Okay? Guys, work hard for the exam. Okay, work hard for the exam, guys. Has all of you got your test paper back? Well, I got plenty of. Have all of you got your test back? The in-class test. Yeah. Alright guys, have a good night. Alright. Send me an email in the No, not this equation. You only need to know the three reduction rules. In this one, do not come. Do not come in the exam. Only the three reduction rules in the formula sheet. You have the formula sheet with you. Yes. Yeah. There are only three rules you need to know. Three reduction rules. Not this. This will not come in the test in the exam. What about the exam? Yeah, I know, but for the exam they will not come. For the exam, the final exam or the presentation, yes.
I just ignore those examples.
Yeah, exactly. Yeah.
Thank you very much.
Just look at the formula sheet, man.
Okay, thank you.
Yeah.
When you finish your lecture, it opens.
Are you guys okay?
Yeah.
Yeah, you're always happy. You look happy all the time.
Oh, really?
Yeah.
That's a good sign.
Did you have the practical? Do you take practical statistics?
Yeah.
You had a test today.
Yeah. In the morning, I finished the exam of that.
Was it easy or?
No, it's a difficult one. It's a quite tough one actually. But
Oh. Okay. Yeah. All right. See you later. See you later, guys.
see you.
See.
See you.
See you, man.
我真打了，要是疼的话，没事，这样就可以。好，没事啊。哎，还要长唇白。